In lecture, we've been talking about how to balance chemical equations. This reaction of hydrogen and oxygen is the first equation that we learned to balance when we started covering this topic. Now, students invariably ask me, why do I need to know this? What's the point of knowing how to balance a chemical equation? And the answer is, it's extremely important. If we want a chemical reaction to work correctly, we have to make sure we have the right amount of each ingredient. The same thing is true with a recipe. Recipes are very much like balanced equations. Recipes tell you what to combine and how much. If you're making chocolate chip cookies, for example, and the recipe calls for 2 cups of flour and 1 cup of sugar, what happens if you use 1 cup of flour and 2 cups of sugar? You're going to get some terrible cookies. So it is very important in everyday life and in chemistry to have a balanced equation. We're going to illustrate this by carrying out that reaction in a Pringles can. This Pringles can has a hole in the plastic end which will allow air into the can, and there's a small hole in the metal end which will allow hydrogen out of the can. And you're going to see why that's important in just a moment. So let me put on my safety glasses and we'll go ahead and fill our Pringles can with hydrogen. So we'll turn on our hydrogen tank. If you listen to the pitch of the sound, you can tell it rises as the can fills with hydrogen. Hear how that pitch got higher there? That should be sufficient. So our can is now completely filled with highly explosive hydrogen gas. I'm going to put on my hearing protection and then let's light it. So we'll peel off the tape and very carefully light the can. Oh, that was not very exciting, was it? I'm sure you were expecting something a little more impressive. That little pop was hydrogen gas igniting as it leaks out of the top of the can. I can feel the heat from the flame that's burning. But why didn't the can explode immediately? Here's a can full of highly explosive hydrogen gas. Very little happened. The answer, of course, is in our balanced chemical equation. You need hydrogen and oxygen in order for this reaction to occur efficiently. Now, as the hydrogen leaks out the top of the can and burns in air, air is moving into the bottom of the can. And the oxygen and hydrogen are slowly mixing together, and they're eventually going to reach that perfect 2-to-1 ratio. When they do, the can's going to make a whining noise. And that tells us in about 15 seconds, boom, and there we go. I hear the whining. So I'm going to step back and put on my hearing protection again. That was pretty impressive. I could hear that right through my headphones. Now, I used to do this demonstration for my kids. When they were little, they loved the Pringles can demonstration. And every time I did it, they always said the same thing. Do it again, Daddy. So let's do it again. I first saw this demonstration at a science conference 30 years ago, and I thought it was pretty amazing. So when I got back to my college campus, I thought I've got to do this for my students. But like most demonstrations that I see, whenever I see a demonstration, I always like to expand it, make it more exciting and bigger. If you remember the Coke and Diet Coke demonstration we did the first week of class, that demonstration originally was only 2 cans, 1 Coke, 1 Diet Coke. We expanded it to 5 to make it more interesting. So when I got back, I thought, you know what, it would be fun to try 2 cans. So let's do that. Let's use 2 Pringles cans and see what happens. Now, your job in this demonstration is very simple. I would like you to predict which of the 2 cans is going to blow up first. So let's fill these both up, and then we'll light them. Again, if you listen to the pitch, you'll be able to tell when the can is pretty full of hydrogen. That sounded pretty good. There's our first one. And the second. All right, now these shouldn't blow up for about 1 minute and 15 seconds, but just to be safe, I'll put on my hearing protection while I light them. So let's peel off the tape on the first one. There's that little pop. And the second one. And there we go. So it should take about 1 minute and 15 seconds. In about a minute, we'll hear the whining sound. About 15 seconds later, it should go boom, and it will be a big boom. So how many of you think the can on the right side is going to go off first? Okay. How many think the can on the left side is going to go off first? Well, let's watch very carefully. Shouldn't be too long, and we'll hear that whining begin, and when it does, I'm going to put my hearing protection on because 2 cans is very loud. So let's listen carefully. Should be happening any time. Come on, cans. There we go. The whining has started. So I'm going to step back a bit this time. Well, that shook the room. You probably can't tell through the camera. That was loud. Now, you probably noticed that the cans appeared to explode at the same time. The first time I did this, 30 years ago, that's what happened. I was amazed. I thought, what are the odds that those 2 cans will blow up at the same time? I did it again, same result. I did it dozens of times. Every single time the cans exploded at the same time. I used 3 cans, 4 cans, even 5 cans, all of them at the same time. Now, I always had a theory that the cans weren't really exploding at exactly the same moment. My theory was that one can was exploding and the shock wave from that explosion was setting off the other cans. Unfortunately, 30 years ago, I had no way of testing that theory because sound travels over 700 miles an hour, so the time required to go between the cans would be very, very tiny. And I needed a high-speed camera that could film in slow motion so we could actually see that. In I think it was like maybe 2015 or so, Apple came out with the iPhone 6. And the iPhone 6 had the ability to film 240 frames per second. One of my students had a brand new iPhone 6, so I had him set up over here, and we put one can here, another can on the far side of the lab, and then we lit them. I had calculated that it should take about 1/100th of a second for the shock wave to travel that 40 feet across the lab. So we looked at his video, the can here went boom, and 1/100th of a second later, boom, off went the can across the room. So it took 25 years, but eventually I was able to test and confirm my hypothesis. Now let's slow this video down to 1/100th of the original speed and see if we can truly tell that one can is blasting off before the other. So begin the countdown. 5, 4, 3, 2, 1. Well, as they like to say on Mythbusters, myth confirmed. Now, as I said, whenever I learn a new demonstration, I always like to make it bigger and better. Many years ago, I was doing a chemistry show for the staff at the college. We were doing a big room here, and I thought, you know what, I'm going to need something bigger for that. So I got a 3-pound coffee can. I thought, well, this ought to really be good. Now, normally I always test my demonstrations ahead of time. That was a rare instance where I didn't do it, and I live to regret it. We went to the auditorium. I filled my coffee can with hydrogen. Hadn't put my hearing protection on because I thought I had plenty of time. Peeled off the tape, and when I lit that thing, it was a massive explosion. Oh my God. I could barely hear for the next 3 hours. Everything was like just a hum in my ears. So I learned that you've got to be real careful when you scale things up. So what had happened is I hadn't put enough hydrogen in the can, and I'd still left air in there. Didn't realize that. So no more 3-pound coffee cans. But I will go a little bit bigger. We're going to do it again with this picnic can, it's little picnic sticks there. And it's about twice the size of your normal Pringles can. It's going to be very loud. So let's go ahead and fill this one up. We're going to have to fill this a little bit more because we want to make sure all the oxygen's blown out of this can. That should be sufficient. Now this one is going to be loud. So I'm going to put on my hearing protection just in case it does what the coffee can did. Let's hope not. We'll peel off the tape. Whew. All right. Now this can is going to take a bit longer because it's bigger. It's got about twice the volume, but the opening on the top is still the same size. So we'll pause the video for a minute or so until it gets ready to blow, and then we'll start up again. Well, there it goes. The winding has started. This is going to be loud. You can feel that in your chest when that goes off.